Let's take a look at the remainder and factor theorems today. So the remainder theorem is saying the value of f of x, meaning that if you do f of x of whatever, plug the number in that you want, you're going to get a 0 here. It's the same as the remainder, or we're going to get whatever the remainder is if we were to divide it. So in this case, we'll get zeros with this. First, let's do the factors of this one, which is x plus 2 and x plus 5 equals 0. Now I'm going to do, well, for the factors, I'm just doing that right now. Okay, so what we're going to do is to solve for the zeros for it. Now for the zeros, we find them by making each of these 0. X plus 2 is equal to 0. X plus 5 is equal to 0. So we get x is equal to negative 2. X is equal to negative 5. But that means if I do two things with it, okay, I'm going to here with factors, where would I put it here? Okay, I'm going to come over here and say that f of negative 2 is equal to, let's put negative 2 into this. Let's see what happens. Negative 2 squared plus 7 negative 2 plus 10. So that means that f negative 2 is 4 minus 14 plus 10, which gives us negative 10 plus 10, which gives us 0. Over on this side here, I'm going to do synthetic division with that negative 2. I take the opposite of this form, or it's the actual 0 itself. And I put negative 2 in here. 1, 7, 10. Bring the 1 down, multiply to get negative 2, add them to get a 5, multiply to get a negative 10. I get 0. Notice that the 0 we get here matches the 0 remainder. So this one's the remainder, the result there. So that works with this. Okay, so it means that if I plug this in, or if I do synthetic division, I will get the same result. The reason that the synthetic division is more useful most of the time is because it gives us a depressed polynomial. That'll be x plus 5 as the result, the quotient. So we're actually doing dividing. Okay, I'm going to do the same thing here with the 5. So f of negative 5 is equal to, if I put negative 5 in the square root, I get 25. And that's going to be minus 35 plus 10. Well, that's negative 10 plus 10 equal also, and that means I get a 0 if I use negative 5. And over here, I'll do long division with the negative 5. 1, 7, and 10. 1, negative 5, add them and I get a 2. Multiply these, I get a negative 10, and I do indeed get that 0. So whether I plug it in or divide it, I'm going to get the same remainder or the same result. All right, so let's do this here, okay, with first doing the f of x. So I'm going to do, and in fact I have this set up, so we'll put we have to make that equal to 0, so we have to say x equals negative 5. So minus 5, and this time it's with a cube. So it's not the one that's above, this time it's a different one. So I'm going to do negative 5 here, cubed, minus 5 times negative 5. We've got lots of 5s in this one, plus 2. So this function with negative 5 is negative 125 plus 25 plus 2. I don't know why I put a 1. That equals negative 98. So that's what we get for that one. Now let's do it with synthetic division. Notice from this format I have to use the opposite sign and then 1. Now notice that there is no x cubed in there. So what we have is plus 0, not cubed squared. We have to do x squared. I'm going to show that over here. X cubed minus 5x plus 2. That's a first power. And this we could, if we wanted to, say x to the 0. But we're missing the 2. It has to be in order, and you have to have a 2 synthetic division. The reason we don't have a 2, the exponent 2 for an x, is because the coefficient that multiplied to it was a 0. And we have to use that 0 in the synthetic division. So here's the 0. And then I will put the coefficient of the -5 and the constant of the 2. So now bring the 1 down and we get -5. Multiply these, I get a 25. Add them, I get a 25. Multiply them, I get a -125. And add them, I get a -130. Oh, it's a positive. Okay, look, why am I off here? Oh, I did not write a 1 here. So hold on, let me go back and fix these. I wrote -5 there when I meant to write 1. So multiply those gives a -5. Add these gives that. Multiply them gives me a 25. 25 minus 5 is 20. Now when I multiply these, I get -100, and then add them for a -98. So this shows that I have the same remainder. Same as the y value and remainder. All right. Let's do the same thing here with a different polynomial, and this time using, is x plus 2 a factor? Well, let's find out. All right. So if we get a 0 here, if we get that all this comes out to 0, then x plus 2 is a factor. So we have to use the opposite sign here, and then we're going to plug it in. So it's -2 cubed plus 2, -2 squared, minus -2 minus 2. So I get a -8, f at -2, -8, let's see, that's a positive 4 times 2, that's +8. Here's +2 and -2. And all of that, the 8's cancel, the 2's cancel, we do indeed get a 0. So it is a factor, and let's see what happens when we do synthetic division down here. 1, 2, -1, -2. No need for a 0 this time, because we have x to the 0 here, and x to the 1, 2, and 3. Bring that down. Multiply these and bring it up here is -2. 2 minus 2 is 0. -2 times 0 is 0. Add them and I get -1. Add these and I get a positive 2. Now when I do -2 plus 2, I get a 0 here, which means that this is indeed one of the zeros of the polynomial, and this is indeed a factor of the polynomial, since those count as the same. Okay. Match. Therefore, x equals -2 is a 0, and x plus 2 is a factor. I should put they match. Okay, good, got that there. Now, let's do one where it is not a 0. Use the remainder theorem to find the remainder of this. All right, so I'm going to do two things. I'm going to do it as f minus 7. Oh, I put a 2 for some reason. There, minus 7. And then we're going to put that 7 into these spots. So I'm going to put, or -7. -7 cubed, minus 2, -7, minus 8, -7. So that gives us, well, let's find something I'm not using. -7 to the third power is -343. And this is negative, oh, I forgot to put the squared there. That's 49 times 2, but it's -2, so it's -98 or -98. And these two negatives make it plus 56. So the function at -7 results in -385. Now, separate from that, let's do the synthetic division. So we'll change the sign, make it -7, and then I'll put 1, -2, and -8. Now there should be a 0 at the end also, because notice that there's no term after that. In reality, this is x to the third minus 2x squared minus 8x plus 0. And that's because if I wanted to be truly technical, I would say there's an x here that's to the 0 power. So that we have a 0, a 1, a 2, and a 3. So they have to be in order going up from the end. So that means I'll put that 0 there. That will give us the correct remainder. So 1, multiply to make -7. Add makes -9, multiply makes a 63, add makes this a 55, multiply and I get a -385, and so that gives us -385. If I had not put the 0 there, I would have stopped with 55, and that would have been wrong. So it's important to remember that there's that 0 there for this. Okay, but notice now that we got a -385 as a result of plugging -7 in. We also got a -385 as the result of the remainder of doing synthetic division. So that proves that you can do it with that thing. Okay. Now the last one, use the factor theorem to determine if this is a factor. Show the quotient that results from using the factor theorem. Show the quotient means you have to do synthetic division. Because when you come on back up here, if I do this method, then there is no quotient. I'll write that. No quotient, just the y value. Here we do get a quotient, which would be as a depressed polynomial, 1 times x squared minus 9x plus 55. So here what we want is the quotients. That means we have to do synthetic division. So that means x equals -2. Okay, and now I see -2x, actually it's the same one there. 1, -2, -8, and then putting the 0. So we get the 1 and -2. So, we did this one with a 7. That's right. The one above was with x plus 7. Now we're doing it with x plus 2. So it is a little different. -2 times 1 is -2. Add them to get a -4. Multiply these to get an 8. And I get a 0 here. But I still need to continue and multiply to get a 0 and get a 0 there. So this would be x squared minus 4x. And that would have helped us then to get the other ones if we needed to. Okay, but, and that's what we want. We want x squared minus 4x is what we get here. I could go further and do plus 0, but I really shouldn't. We don't do that as normal writing, only when we need to in the process of calculating. So this is the solution for that one. All we wanted here was the synthetic division depressed polynomial, or the quotient from it. Okay, and we got that from using these coefficients and starting with 1 exponent less. Instead of the cube that started off this one, we do 1 less to make it squared. Well, hopefully that helps with recognizing the using the remainder theorem and the factor theorem. In fact, I should put down here, the factor theorem is that one. Okay, so please practice these and hopefully comfortable for them. Thank you for watching and listening.